So the second thing we're going to use in coordinate geometry is we are going to maybe find the distance between 2 points. So we want to find the length of a segment joining 2 points. This will help us show that segments have same equal lengths, which will then help us show that things are congruent. So if x1, y1, and x2, y2 are points on the graph, then we can use the distance formula, the square root of the change in x's plus the change in y's. Now, if I have a horizontal or a vertical line, just count the boxes. No need to use a formula for that. And the distance formula is actually the Pythagorean theorem, a squared plus b squared equals c squared in disguise. So if I have 2 points that I've plotted and I've connected them, what I'll need to do is I'll drop a perpendicular, draw the horizontal. I now have a right triangle where my legs are A and B, and the length of the hypotenuse will be C. So I can also use the Pythagorean theorem, but I just have to pull out a piece of graph paper if I want to use that. So what we'll do for number 7 is we'll use both ways to try to show you maybe which one you're going to pick to see which one you like better. So I'm going to write down my distance formula first. So I've got my change in x's squared plus my change in y's squared. So plugging in my points, don't forget to continue to put the square root over everything. I've got 5 minus 0 squared plus 4 minus 4 squared. Simplifying further, we have 5 squared plus 0 squared. So my distance, the square root of 5 squared, which is 25. So the distance between those 2 points is 5 units. Now, if I were to use the Pythagorean theorem, I would probably need graph paper or to sketch out my points. So if I sketch out my points carefully, I've got a point here, and I've got a point here, and if I just connect those, I see that it's a horizontal line. 5, I don't need any other formula there. Now it's going to be horizontal. So let's go on to number 8. So my distance formula, square root of the change in x's squared plus the change in y's squared. Plugging in my points, we've got 3 minus negative 3 squared plus 3 minus negative 2 squared. So 3 minus negative 3 is going to give me 6 squared. 3 minus negative 2 is going to give me 5 squared. So evaluating this, we've got 36 plus 25. So my distance between the 2 points, let me grab a calculator for this one. I've got the square root of 61. Now it does say to round my answers to the nearest tenth. So the square root of 61 is approximately 7.810249676. So my distance, or to be more precise, the length of OP, we're going to consider a 7.8 as my rounded value. Okay. Number 9. My distance formula, the square root delta x squared plus delta y squared. Plugging my numbers in, got 3 minus negative 3 squared plus negative 3 minus 6 squared, which is going to leave me with 6 squared plus negative 9 squared. This is the square root of 36 plus 81. And if I add 36 and 81, that's going to give me the square root of 117. Now, 117 does have a perfect square, so this is going to break down into the square root of 9 and the square root of 13. So in simplest radical form, we've got 3 radical 13. Now, if I were to plot these points, so -3, 2, 3, 4, 5, 6, and 3, -3. So if I connect T and U, I connect these, I drop a perpendicular, draw that over, so I now know that this, just by counting, has a length of 6. By counting, this has a length of 9. So if I'm using the Pythagorean theorem, a squared plus b squared equals c squared, we end up with 6 squared plus 9 squared, and we're looking for the length of TU, so TU squared. So 36 and 81 is TU squared, and hopefully we're seeing the parallels kind of between each of these formulas. 117 equals TU squared. Take the square root of both sides, and my answer, TU, is the square root of 117, which we've just simplified into 3 radical 13. So same answer. So it's really going to be up to you on which method that you'd like to choose. So in number 8, let's just straight do Pythagorean theorem with this one. So again, I pull out a piece of graph paper or sketch very carefully. 3, 2, 3, 4, 5, 6, 7, 8. 3, -8. -2. 1, 2, 3, 4, 5. And I'm going to connect those. And I'm going to make myself a right triangle. So I've got my Q. I've got my R. So now when I count these, I see that this has a length of 3. I see that this has a length of 5. So I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. 3 squared plus 5 squared is going to equal our QR squared. So 9 and 25 is going to give me 34. And so if I take the square root of both sides, I've got QR is radical 34. That can't be broken down, so that's what we're going to leave as our answer.